Myself Venkateswarlu from the AI&ML department. I'm handling the subject Discrete mathematics subject. So this is the concept in the fifth unit. So about the spanning tree we are discussing today in the class. So what is spanning tree? So how to construct the minimum spanning tree we are discussing in this class. So what is, first of all, we know that what is the spanning tree. So spanning tree will be constructed from the given graph. So the graph may be the directed graph or undirected graph. Then let us suppose I am taken here one graph. So graph is having the some vertices is A, B, C, D. So with the edges of AB with the cost is 1, BC with the cost is 3, CD with the cost is 4, AD with the cost is 5, and BD with the cost is 2. This is called a weighted graph. So for the weighted graph, we are finding the different spanning tree. So which spanning tree gives that minimum cost without forming the cycle. So spanning tree construction will be constructed by the given graph without forming the cycle. Okay, with the maximum number of vertices with the minimum number of edges. So with their cost. So let us suppose this is the example of the graph. This is the spanning tree. So spanning tree is having the maximum number of vertices with the minimum number of edges which cover the all the vertices without forming a loop. Let us suppose we are taken this here, this becomes as a loop. So we are discard this loop of the cycle of the graph for maintaining the spanning tree. So that's why here the cost of the spanning tree here is 1 plus 3 plus 4. So whatever the edge weight, so we taken that is the cost becomes 8 for this spanning tree. So let us suppose I am constructing the one more spanning tree for this graph with the all the maximum number of vertices with the minimum number of edges without forming the cycle. So with their cost 1, 2, 3. So their total cost becomes as 6 here. So among these two spanning trees, so this gives the less cost for constructing the spanning tree. That's why here it is called that the minimum cost spanning tree. Minimum cost spanning tree. So this is shortcut, we can tell that minimum cost spanning tree construction. So among these two spanning trees, this is the minimum cost spanning tree. So today class we discuss about the two different algorithms, but today we covered the one algorithm, that is the Prim's algorithm. KRUSKAL'S algorithm. Okay, we can construct the KRUSKAL'S algorithm. We are using the KRUSKAL'S algorithm for constructing the spanning tree for the given graph. For constructing the spanning tree for the given. This is the given graph with the weight edges, whatever weight of the each edge, with having that whatever the total number of vertices is there, and different edges are there with their cost. Okay. So now how to construct the minimum spanning tree by using the KRUSKAL'S algorithm. Today we are focusing on this topic. Okay. Now first of all, so we follow some algorithm here. So first we need to note down that whatever the edge cost is from the ascending order of their weights. So edge cost means here whatever the 0 to 1, it is a 4. So we are writing that edge cost with the ascending order. Okay. So ascending order means what is the minimum cost among the all the edges here is 1. So let us take that 6 to 7, whatever the edge cost here is, whatever the cost of the edge is 1. Okay. Next with the minimum cost edges 2, 8. So this is over. Okay, this is over. Next with the minimum cost here is 2 to 8 head. So the cost here is 2. Next third edge here we can take in that from 5 to 6. The edge cost here is 2. Then so we construct the amount after the 2. The minimum cost here is edge cost here is 1 to 0 to 1 edge. So the cost here is 4. Okay. Next, similarly we can construct likewise all these 2 to 5. So the edge cost here is 4. Okay. So next the minimum edge cost here is 6. 8 to 6, 6 to 8 we can write that 6 to 8 edge, the cost here is 6. Next 7, the cost is the minimum cost is 7. 2 to 3 edge cost 2 to 3, the edge cost is 7. Next 7 to 8, the edge cost is here also 7. So we are writing like this in ascending order of their edge costs. So after 7, the edge cost here is 1 to 0 to 7, edge cost is 8, and 1 to 2, edge cost is 8. Next 3 to 4, the edge cost is 9, and 4 to 5, the edge cost here is 10. Next 3 to 4, that is over. So 10 is over, 9 is over. So whatever the left cost here is here 1 to 7. So 1 to 7, the edge cost here is 11. Okay. These are all after writing this edge cost. How to we construct the minimum cost spanning tree? So we take down that all the vertices of the given graph 0, 1, 2 because of so spanning tree means so we are constructing the graph without forming the cycle with the minimum weight edges 2, 3, 4, 5 all vertices. We are note down the all the vertices here. So what are up to the 8 vertex are there 0, 1, 2, 3, 4, 5, 6, 7, 8 from 0 to all 8 vertices we noted. Now we taken that minimum cost edge. Minimum cost edge is here 6 to 7 which is having the cost in 1. According to the ascending order of their edge weight we are taken that we are connecting the edge to the these are already noted down the vertices here. So now 6 to 7. So the edge cost is how much here 1. So we are noted down the next 2 to 8. 2 to 8 edge cost is how much? That is 2. This is over. Next 5 to 6. 5 to 6. The edge cost is here is 2. Next 0 to 1. Edge cost here is 4. Next 2 to 5. The edge cost is 5. 2 to 5. So let us suppose that 2 to 5. Yes, this is edge cost is 4. Next 6 to 8. 6 to 8. Let us suppose that here we have taken that edge vertices having 6 and 8 with the edge weight is 6. Let us suppose we have taken this one edge with the cost is this forming the loop. Okay. So whenever that we are taking that edge weight to form the loops, avoid that edges. Avoid that edges. Next to go through the next edge weight without formation of the loops only we are making it. Next 2 to 3. The cost is 7. 2 to 3. The cost is 7. Next 7 to 8. 7 to 8. Let us suppose we are taken this edge here 7 to 8. The cost is 7. But here whenever we taken that edge it forms the loop. So that's why we are avoiding that edge. So we are avoiding that edge. Next to go for the next edge 0 to 7. That is 8. 0 to 7. So this is not forming any loop. So we are consider that edge with the cost is 8. So next 1 to 2. So let us suppose we are taken that 1 to 2 here. It makes the loop here. Okay, this is the loop. So we are avoiding to take this edge cost. Next 3 to 4. So 3 to 4. So this is without forming any loop. So that's why we are considering this weight 9 here. Next 4 to 5. 4 to 5 edge cost is how much? 4 to 5 edge cost is 10, but it forms the loop. So avoiding this one. Next 1 to 7. So 1 to 7 also it will form the loop here. 1, 0, 7 it forms the loop. So we can avoid it. Here we are having the minimum number of edges. So which is connected with the all the vertices of the graph. So this is how to the CRUSKA'S algorithm will be work here. So now we are finding that cost of the spanning tree here. So 4 plus 8 plus 1 plus 2 plus 4 plus 2 plus 7 plus 9. So this is the total cost of the spanning tree. So here 4 plus 8 12, 12 plus 1 13, 13 plus 2 15, 15 plus 4 19, 19 plus 2 21, 21 plus 7 28, 28 plus 9 37. Here total cost of the spanning tree here is 37. This is the cost of the spanning tree. So this gives the minimum cost only. Minimum cost only because of we are adding all the minimum weight edges for the given graph. Okay. This is the way to we solve the problem by using the CRUSKA'S algorithm for finding the minimum cost spanning tree.